Okay, so hello everyone. So in this video, we're going to discuss how to get the volume of a solid of revolution. Okay, define muna natin kung ano ba ibig sabihin natin when we mean solid of revolution. So a solid of revolution, this is a solid obtained when a plane is revolved about a line we call the axis of revolution. So previously, ang kinoconsider lang natin is yung graph sa Cartesian plane. Ngayon, i-extend natin yun kasi yung graph na yun ire-revolve natin about an axis of symmetry. Therefore, we will be getting a three-dimensional figure. Okay? So we will be discussing two methods on how to get the volumes of solids of revolution. But dito sa video na to, magfo-focus tayo sa first method na tinatawag nating disks or washers method. Okay, this is used when we are considering rectangles perpendicular to the axis of revolution. Now, previously, sa pagkuha ng area of a plane region or area of a region, gumagamit tayo ng either vertical or horizontal na rectangles. So, ganun rin sa pagkuha ng volume ng solids of revolution. Gagamit tayo ng rectangular strips. It can either be vertically oriented or horizontally oriented. Okay? For disks or washers method, yung mga rectangles or yung mga rectangular strips na kinoconsider natin ay perpendicular to the axis of revolution. Now, if we would recall, ang formula ng volume, this is equal to the definite integral from a to b ng a of x dx, where we have a of x as the area of the region. Okay? So let's draw an arbitrary sketch. So for instance, this is the graph. Now yung a of x now a of x will technically be this part here. Okay? And then, let's say we're going to revolve it about the x-axis. So if we revolve it about the x-axis, imagine this part here, iikot natin all over the x-axis. Yung figure natin will look something like this. And then, ito na ngayon yung hahanapan natin ng area. Okay? Now, disks or washers method, these are used kapag yung cross-section na makukuha natin. Let's say, dito sa figure na to, mag-insert tayo ng isang plane that will slice this into one part or in one part. Yan, pag nag-insert tayo ng plane dyan, yung makukuha nating cross-section would actually be a circle. And the area of a circle, we know this to be pi r squared. So, ibig sabihin, if we want to get the volume of this region, yung volume natin is definite integral from a to b ng ax dx. So, this will be the definite integral from a to b ng area ng circle ay pi r squared. But now, we want to get the value of r, or we want to get the radius of this one. Kung babalikan natin yung kanyang graph sa two-dimensional space, technically, yung circle natin would be somewhere here. So this entire thing, ito yung diameter, and yung radius niya would be this part here. So yung radius niya is how high it is from the uh, x-axis at yun actually yung y-coordinate nung point na yun. So ibig sabihin yung radius ng bawat circle dito can be described as f of x. So with that, yung volume natin when we're considering discs or washers, this is actually equal to a to b ng pi f of x squared dx. Okay, so for discs or washers, this will be the formula that we're going to use if we want to find the volume of a solid of revolution. Now, anong difference between the two? So kapag discs yung kino-consider natin, we are actually considering a solid of revolution kung saan yung axis of revolution is a boundary of the region. And then for washers, this is when the axis of revolution is not a boundary. Okay? So kung iisipin natin, ano ba ang itsura ng disk ay yung, well, pwede nyo isipin yung ginagamit nyo sa Ultimate Frisbee. No? Yung washers naman, pwede nyo itong isipin na yung lumang 5 centavo coin. Okay? Or mukha siyang ring, mukha siyang donut. Okay, so let's consider this example here. So find the volume of the solid generated when the region bounded by y equals x squared, y equals 0, and x equals 3 is revolved about the x-axis. Okay, so we have here the graph of the region. So this one is y equals x squared, this is y equals 0, and this is x equals 3. Now suppose we will revolve this about the x-axis. By the way, gagamit tayo ng discs dito. Okay? So drawing ko lang yung sketch very briefly here. Okay, so what we're going to use is we're going to be using vertical rectangles. So bakit vertical rectangles? Kasi yung axis of revolution natin, it's a horizontal line. So kino-consider natin is yung orientation ng rectangular strips to be perpendicular. So in this case, vertical yung ating rectangular strips. Okay, so the region would actually look like this, or the solid of revolution would actually look like this. Now I have here GeoGebra, which will help me illustrate how the region will look like, or the solid of revolution will look like. Okay, the solid of revolution will look like this. Yeah. So ito yung hahanapan natin ng volume. So para mas clear, dito sa view na ito, so the solid of revolution would look like this. So itong nasa loob, ito yung hahanapan natin ng volume. Okay, so the volume will be equal to pi f of x squared dx. Okay, since we're using vertical rectangles, so yung limits of integration natin would be from 0 to 3, or yung part sa x-axis. So the volume would be the definite integral from 0 to 3 pi. And then yung f of x natin, this should be the radius of each circle. So yung radius niya, etong part na to, which varies as we go along this curve. No? So this would actually just be x squared dx. Okay, so simplifying, we have that the volume is equal to 0, the definite integral from 0 to 3 pi x to the 4th dx. Applying FTC2, this will give us pi x to the 5th over 5. Evaluate from 0 to 3. So this is 3 to the 5th over 5 times pi. That is 243 over 5 pi. Since this is volume, ang unit of measure natin would be cubic units. Okay, so hopefully clear ang ating first example. Okay, for our next example, find the volume of the solid generated when the region bounded by y equals x squared, y equals 0, and x equals 3 is revolved about the x-axis. So this is technically the same region, no? But this time, iba yung axis of revolution natin. Okay, drawing ulit natin yung sketch ng region natin. Extend ko, no? Kasi iba nga pala yung axis of revolution natin. Okay, this is our region. And then we want to revolve it about the line x equals 3. This is the line x equals 3. So, i-revolve natin dito. Ang itsura ng ating region or ng ating solid would look like this. Oops. I forgot to turn this off. Yan. Would look like this. So, dito sa view na ito yung ating solid. Okay? Now, since iniba natin yung axis of revolution natin, ang axis of revolution natin is now a vertical line. Since we want to use discs or washers, yung rectangular strips na i-consider natin would be horizontal rectangles. Okay? So, since horizontal rectangles yan, ang ating basis ngayon is yung limits natin ay nasa y-axis. So, this would be from 0 to 9 pi times kung ano man yung radius natin, dy. Okay? Again, since horizontal na yung rectangular strips na ginamit natin, yung integral natin will be over the y-axis. So now, we need to find a way to write the radius in terms of y. Notice that the radius of each circle would actually be this part here, no? Itong part na to. Okay? So, magsisimula tayo sa radius equal to 3. However, as we move along the curve, or kung aakyat tayo dito sa graph na to, yung radius notice ay paliit ng paliit. Depende kung nasan na yung position ng curve na to. So, kung wari nandito na tayo, yung radius natin would just be this part here compared dun sa radius natin. Yung radius natin dito sa baba. Now, yung radius sa baba, will just be equal to 3. Pero pag nandito na tayo, this should be obviously less than 3. So, paano natin isusulat yun in a nice way? Now, notice that we have y equals x squared. Pero since we're using horizontal rectangle. So, si y equals x squared, isusulat natin to as x equals square root of y. So, itong part dito, this is again x equals square root of y. And then, as we go along, or as we go up, as we travel up here, yung radius natin paliit ng paliit. Okay? So, magsisimula tayo sa 3, pero as we move along, or as we move up the curve, this will be 3 minus square root of y. Because square root of y would pertain to points on this curve here. So, obviously, yung x value ay 3 initially, pero binabawasan mo siya as we move along the region. Okay, so, yung radius natin, yung 3, yung maximum, minus yung kung nasaan na siya dito sa curve na to. So, we have that the radius is 3 minus square root of y. So, our volume will be the definite integral from 0 to 9 pi times 3 minus square root of y squared dy. Okay, solving this part here, we have definite integral from 0 to 9. Labas ko yung pi. Simplify, we have 9 minus 6 square root of y plus y dy. We apply FTC2. Pi times 9y minus 4y raised to 3 halves plus y squared over 2. We evaluate this from 0 to 9. So we have pi times 81 minus 4 times 9 raised to 3 halves plus 81 over 2. Minus pi times 0 kasi at y equals 0, lahat to magsi-0. So pi times 81, this one when simplified, 9 is 3 squared. So magiging 3 na lang ito. Then 3 cube is 27. Then plus 81 over 2. And again, simplify. We have 81 minus 4 times 27, that is 108. So 81 minus 108 plus 81 over 2. This gives us negative 20. Negative 27 plus 81 over 2. 7 over 2 by cubic units. Example for this video, we want to find the volume of the solid generated when the region bounded by y equals x squared, y equals 0, and x equals 3 is this time revolved about the line y equals 9. Tabo coin, or mukha siyang ring, mukha siyang donut. So, yung cross-sectional areas natin would look something like this. So, meron tayong dalawang circles. Okay? Yung dalawang circles na yon may magkakaibang radius. Let's say yung mas malaki or yung mas maliit, let's call that R1. Then yung mas malaki, let's call that R2. So technically, ang area nito would be yung area ng mas malaking circle minus yung area ng mas maliit na circle. So in turn, parehas pa rin sila na pi times r squared. Yung r squared nga lang natin dito would be the difference between the squares of the two radii. Okay? So let's draw a quick illustration kung ano itsura ng magiging solid natin. And then later on, papakita ko rin yung itsura niya sa graph. Okay, let's say this is y equals x squared, 0 to 3, and then ito yung y equals 9. So, yung axis of revolution natin is a horizontal line. Therefore, we're going to use vertical rectangles. Now, we're going to revolve it about this line. So, yung itsura ng ating solid would look something like this. Yan. Okay? Now, tingnan natin yung magandang itsura ng solid. No? Okay, the solid would look like this. So, from this view, yan. So, ito yung hahanapan natin ng volume. Would now be the volume is equal to the definite integral from 0 to, we use vertical rectangles. So, it's along the x-axis. So, 0 to 3 pi times r2 squared minus r1 squared dx. So, we now have to find r2 and r1. Okay? Balikan natin yung itsura nung solid natin. Yung solid natin, meron tayong malaking circle, ito, na constant technically yung radius nito. And then, yung maliit nating circle, yung nasa loob. Okay? Etong part na to. So, yung R2 natin, yung constant radius na yon ay actually equal sa 9. So, etong part na ito yon. And then, yung mas maliit na circle natin, yung R1, ang nangyayari dun is, galing tayo dito. So, if we revolve this about the line y equals 9, same yung radius niya. Pero as we go along, or as we travel this curve, liliit ng liliit yung radius ng circle na yon. Okay? And that is given by 9 minus x squared. Because this graph here is y equals x squared. So, ang nangyayari is yung constant na 9, nababawasan siya as we travel along this curve. So, we have R2 equals 9 and R1 equals 9 minus x squared. So, if we substitute, this would be the definite integral from 0 to 3 ng pi times 9 squared minus 9 minus x squared dx. I simplify pi times the integral from 0 to 3 ng 81 minus quantity 81 minus 18x squared. Oops, sorry, this should be 9 minus x squared plus x to the 4th dx. Okay, pi, simplify 0 to 3. Magka-cancel yung 81. And then minus minus, so 18x squared minus x to the 4th dx. Apply FTC2. So this one will give us pi times 6x cubed minus x to the 5th over 5. Evaluate from 0 to 3. Now, at x equals 0, magzi-0 lang tong part na to. So, we just have to evaluate it at x equals 3. So, at x equals 3, we have pi times 6 times 27. Fifth is 243 over 5. Okay, simplify. We have here 162 minus 243 over 5. Or, 810 minus 243 over 5. So this gives us 567 over 5 cubic units. Okay, so it's a bit tricky, especially kung hindi natin ma-visualize yung itsura ng solid. That is why maganda mag-drawing ng sketch ng illustration natin kahit medyo pangit yung makukuha or hindi masyado maganda yung solid of revolution na nakukuha ng sketch natin. Okay, so in the next method, we're going to discuss yung isa pang technique on how to get solids of revolution. Yun naman ay using cylindrical shells.